And welcome back to our discussion of Unit 5, Revolutions. This is topic 5.5, Technology of the Industrial Age. The thematic focus of this lecture is going to be technology. And by the end of this lecture, I want you to explain how technology shaped economic production over time. Historically, the development of machines, including steam engines and the internal combustion engine, made it possible to take advantage of both existing and vast, newly discovered resources of energy stored in fossil fuels, specifically coal and oil. The fossil fuels revolution greatly increased the energy available to human societies. The Second Industrial Revolution led to new methods in production of steel, chemicals, electricity, and precision machinery during the second half of the 19th century. Railroads, steamships, and the telegraph made exploration, development, and communication possible in interior regions globally, which led to increased trade and migrations. So thus far, we talked about the Industrial Revolution in fairly general terms. This era, it is categorized by two distinct industrial events, and those are referred to as the First and Second Industrial Revolutions. The main difference in these two revolutions is their respective effects on production. The changes which each brought are what historians use to categorize these periods in industrialization. So, taking a look at the slides here and taking a look at the boxes in your guided notes packet, you'll notice that the First Industrial Revolution has already been done for you, and we're going to compare how that changes into the Second Industrial Revolution, so make sure to write down these points into the Second Industrial Revolution box. So in the First Industrial Revolution, which occurred from the late 18th to the mid-19th century, versus the Second Industrial Revolution, which is the late 19th to early 20th century. Under the First Industrial Revolution, we see things like textiles, iron, and steam power, versus the Second, where it's now focused more on steel, oil, electricity, and chemical production. Under the First Industrial Revolution, we see the development of a factory system, whereas in the Second, it moves to mass production and assembly lines within those factory systems. In the First Industrial Revolution, we see the development of railroads and canals, that innovative technology of that time, whereas in the Second, the innovative technology is going to be the automobiles. We see in the First Industrial Revolution, urbanization, and then in the Second, consumer culture. So once again, make sure to mark those down into your guided notes. So we can think of the First Industrial Revolution as the first wave of innovation that leads to the Second Industrial Revolution. The factory system develops, and within that development, we see improved steam power, which helps extract coal from mines, automate parts of textile production, and it provides a way to power trains and steamships for transporting goods. The rise of the factory system, it also goes hand in hand with urbanization, and the growth of urban centers was an important factor in the Second Industrial Revolution. The Second Industrial Revolution, it yields many of the modern inventions, or at least their precursors, that we know and enjoy today. So think about cars, gasoline, phones, the lights in your classroom right now. All of these things, they stem from the Second Industrial Revolution. The effects of industrialization began to be felt, and we will explore these in more depth in later topics in this unit, but they spurred movements to regulate this new era of industry. Okay, so let's talk about the fossil fuels revolution. And as I'm going through this slide, make sure to fill in the blanks for coal and oil. You'll notice natural gas has already been done for you in the guided notes packet. The fossil fuels revolution, which is part of the Industrial Revolution, was a period marked by the discovery, utilization, and widespread adoption of fossil fuels as primary energy sources. This revolution drastically transformed industries, transportation, and economies, catalyzing unprecedented growth and development. Coal kicked off the fossil fuels revolution by making steam-powered machines a reality. We know that Britain had access to coal, and this was one of the factors that made Britain the leader of the Industrial Revolution. Oil replaced coal as a fuel source in many industries during and after the Second Industrial Revolution. The first commercial oil well was set up in 1859 in Pennsylvania by Edwin Drake, and this was considered the beginning of the oil industry. And while we include natural gas in this list of fossil fuels, it does not have a huge impact on economic processes and innovations until a bit later, so after 1900. So what are the advantages of oil over coal? Well, crude, meaning unrefined oil, has been used in some way by humans for thousands of years. However, oil found new uses during the Industrial Revolution, and it eventually replaced coal in some industries. Oil, it burns cleaner than coal and can produce more energy than coal. And also, it is much easier to store and transport because it's liquid as opposed to solid chunks of coal. The oil industry began to grow after commercial oil wells were drilled in the United States and Canada. So pictured here is an oil well in Galicia, Spain in 1881. So the oil industry, it begins to change. Kerosene lamps. Ignacy Lukenswitz was a Polish pharmacist, significantly improved kerosene lamp technology using local petroleum. His innovation, it gained attention on July 31st, 1853, when his lamps were used for an emergency operation at Lviv Hospital, offering bright and clean light. Impressed, the hospital ordered more lamps and more fuel. Recognizing the potential, Lukenswitz left his pharmacy job, secured a business partner, and patented his technique in Vienna. He then established several wells and refineries in southern Poland by 1859, advancing the use of kerosene lamps. Most notably, however, the oil industry sparked the advent of the automobile and revolutionized the transportation industry. After coal and steam power had done so with trains and steamships, of course. You also have heating and electricity becoming oil-dependent industries because of how much more efficient it was than coal. Plastic is something we use and see every day, and it is derived from oil. You can look around the room and see just how much plastic you can find, noting that it's the oil industry during the Industrial Revolution that we have to thank for all of this plastic. And that moves us to the internal combustion engine. An internal combustion engine in a car works by burning fuel, usually gasoline, inside a small chamber called a cylinder. When the fuel burns, it creates a high-pressure gas that pushes on a part called a piston. This piston, the movement of the piston, turns the crankshaft, which ultimately powers the vehicle's wheels. One of the very first internal combustion engines, Pyrophore, shown on this slide here, was used to power a riverboat in France. That engine used finely crushed coal dust as fuel, but it never took off as a commercially viable product. But a frenzy of sorts. It developed by the mid-1800s, in which scientists and engineers in Europe and the United States were designing various versions of internal combustion engines. The reason they were interested in this internal combustion engine is because it led to personal automobiles. Carl Benz, who was a German engineer, and he is connected to the Mercedes-Benz company, which comes later, patented his combustion engine in 1879 and developed the first commercially available automobiles. And images of that will be found on the next slide. Now, you don't need to really know when the first liquid-fueled rocket was launched, but it's interesting that we have the first real car in 1886 and the first rocket launches in 1926. That's only 40 years between cars and rockets. So here we have some images of some of the first Benz automobiles and the very first driver's license, which was issued to operate the Benz patent motor wagon, which is pictured on the bottom left, on public roads in August of 1888. So electricity, it becomes practical. The late 19th century saw major breakthroughs in electrical engineering, transitioning electricity from scientific curiosity to practical use. Key figures like Thomas Edison, Nikola Tesla, and George Westinghouse, all three pictured here, were instrumental in developing practical electrical systems. Thomas Edison's invention of the incandescent light bulb in 1879 and his development of electricity distribution systems revolutionized indoor lighting. Nikola Tesla's work on alternating current, which is AC, systems allowed for efficient long-distance electricity transmissions. And George Westinghouse's purchased patents from Nikola Tesla in 1888 that were critical for building a functional AC power system, including the induction motor and transformer designs. Okay, so over the next two slides, we're going to talk about the effects of electricity. And I want you to be able to write down in each area the different effects, whether it's industrial productivity, urban and domestic life, communication and transportation, or cultural shifts. So make sure to fill in those blanks with the information on these slides. The ability to send and use electricity in a practical manner had massive effects on industry, lifestyles, communication, transportation, and culture. Industrial production benefited from increased efficiency and greater flexibility. Electric power meant that factories did not need to be located along waterways, and they were less reliant on coal. Additionally, electricity greatly impacted machinery used in production and increased mechanization, leading to an increase in overall production rates across various industries. For people, electricity, specifically lights, effectively made the days artificially longer. People could work longer hours with reliable lighting, but could also do more on their own time as well. Household appliances changed the way domestic work was done, increasing efficiency in the home. So modern communication is fully dependent on electricity. Early communication systems like the telegraph needed electricity to function. Without electricity, information needed to be physically transferred. Think the Pony Express. Much of our modern transportation systems, they rely on electricity, like the subway in dense urban areas. The widespread adoption of electricity marked a really important cultural shift. The idea of convenience in our everyday lives was born from this era of new electric devices that could work for us. The entertainment industry exploded after the invention of the radio and film. Most of what we consider to be a part of our culture today, music, movies, video games, etc., that wouldn't be possible without electricity. So let's look at this real quick. Technologies that shrank the world. When we talk about shrinking the world, we mean connecting the world in ways which were previously not possible. A key point for you in this portion of Unit 5 is to be able to identify some technologies which connected people and places and led to increased trade and migration. Trains, steamships, and the telegraph are three examples of this kind of technology, and we're going to look a little closer at trains and the telegraph. So railroads, they had a tremendous effect on many parts of the world beyond just the industrial powers of Europe and the United States. The landlocked protectorate of Uganda was controlled by the British Empire beginning in 1894. In 1896, the construction of the Uganda-Kenya Railroad began with the goal of connecting Britain's territory to Mombasa, which is in the coastal area of Kenya. Railroads allowed interior regions to become connected to coastal ports, which facilitated commerce and trade. This particular railroad was built with only two endpoints in mind, Kisumu and Mombasa. The space between these two cities was relatively unpopulated in the late 1890s, and when the railroad was completed in 1901, land near the railroad became somewhat desirable, and both European and African populations grew. This railroad is a perfect example to illustrate the last key concept of this topic. Railroads, steamships, and the telegraph made exploration, development, and communication possible in interior regions globally, which led to increased trade and migration. So let's examine the impact that immigrants had with railroads. The development of railroads is closely associated with migration. In the example we just looked at in Kenya, we saw the movement of people to the area close to the Uganda-Kenya Railroad after it was built. In the United States, the building of the Transcontinental Railroad attracted immigrants from other countries. Between 1863 and 1869, about 15,000 Chinese workers helped to build the Transcontinental Railroad between Sacramento, California, and Promontory, Utah. So the industry itself attracted migrant labor. In the United States, the influx of Chinese migrant labor would later lead to the Chinese Exclusion Act, which will be covered in more detail in Unit 6. Pictured here is a tent setup where Chinese migrant workers lived while working on the railroad. White workers were typically given accommodations in rail cars, while foreign migrants had to be set up in tents. So now let's examine the next thing, the telegraph. Samuel Morse was an American inventor and painter, best known for his development of the electric telegraph and the Morse code system. This was a system of transmitting textual information using a series of on-off tones, lights, or clicks. Born in 1791, Morse originally pursued a career in art, but shifted his focus to invention and innovation in the 1830s. His groundbreaking work on the telegraph, which he developed in the 1830s and patented in 1844, revolutionized long-distance communication. Before the telegraph, messages had to be physically carried from one place to another, a process that could take days or weeks. With Morse's invention, messages could be sent over wires across great distances almost instantaneously. This technological leap not only transformed the way information was shared and disseminated, but also had profound impacts on business practices, journalism, and personal communication, ultimately contributing to the emergence of the modern connected world. Morse's invention laid the foundation for future innovations in telecommunication, including the telephone and the internet. So pictured here is Samuel Morse with a telegraph and a diagram of the original design of the telegraph. Okay, so what I'd like you to do here is I want you to examine this map of telegraph lines from 1871. And as you do that, in your guided notes, I want you to answer the question in your guided notes. What do you notice about the locations of the already constructed lines? Those are the green lines. So examine it closely. I know you can't see the green on your guided notes. You're going to have to look at the slide here. What do you notice about the connected green lines? Okay. After you've examined that, I want you to think about this. What seems to be the final goal of these telegraph lines? Okay, so that is going to wrap up our lecture on topic 5.5. There is a graphic organizer for 5.5 that I would like you to complete. That's called the Technology of the Industrial Age. It's in your guided notes packet, so make sure to complete that. For that, what invention or innovation is each of the following people responsible for? What effect did each invention or innovation have on the Industrial Revolution? So we have Alexander Graham Bell. What invention, what effect did he have? Guglielmo Marconi, what invention, what effect? And James Watt, what invention, what effect? Below that, we have the SS Savannah, 1818. What was the SS Savannah famous for? What does SS stand for? And what was one effect of steam-powered ships replacing sailing ships? Lastly, at the bottom, we have the first Industrial Revolution innovations versus the second Industrial Revolution innovations. Make sure to copy those down as well. You also have a spiced tea for this one. Once again, like we did with the last unit, we're going back to Unit 2. There were so many different revolutions that I kind of spread these spiced tea out amongst the various topics. So for this one, we're going back to look at the Latin American Revolution, so you might want to have Unit 2 to help you look at that. For the Latin American Revolution, I want you to look at the social, political interactions with the environment, culture, economics, and technology that affected that revolution. So key ideas for topic 5.5 that you should write down in your separate notebook. The first Industrial Revolution brought much of the technology needed for the second Industrial Revolution. The second Industrial Revolution led to new developments like electricity and chemicals. The fossil fuels revolution kick-started the oil industry and led to increased efficiency in production, the internal combustion engine, better lighting, and new materials like plastic. Electricity transformed industry, domestic life, communication, transportation, and culture. Trains, steamships, and the telegraph enabled a much more connected world. And lastly, railways facilitated increased trade and migration. So make sure to mark those down. And as always, make sure to check out Heimler's topic 5.5 review video that I've posted a link to in the description. Have a great day.